How's it going, guys? I'm Michael Hyde, and I will be going over the Physics 2211 Lab 2. This lab is over trajectory and gravity and drag and their effect on projectile motion. Now, this lab will discuss the impact of the surrounding forces on a non-stationary object. This is otherwise known as a dynamic problem, where forces are acting on an object in motion. These forces will be the force of gravity and the force of drag, which, as we know, the force of gravity is the ball mass, and it will be multiplied times g, which is the Earth's gravity. Now, we also know that the force of drag will be equal to the drag constant times the speed times the unit vector. And this unit vector will show the direction and the magnitude on a 1 unit scale. Now, this will also be going over velocity and its constancy, where this inertia is also known as momentum, and that is the force that will be pulling this object in one direction, regardless of force of gravity and force of drag fighting it and minimizing that. Now, in this experiment, we will be throwing an object in the air, and it will form an arc. This object is a paper ball for our experiment, and it weighs about 20 grams. And when this ball is thrown, there is not a continual force from the person throwing it, meaning that the only forces acting on it will be surrounding forces, which will be constant and will fight the positive y direction of the velocity, and since we flipped the view, the negative x direction as well. And thus, it will not continue forever, so it will fall in an arc. This is some data that we collected from the graphs of the tracker, and this is the simulation that we ran on the tracker. Now, in terms of our code, we did two outputs, one with no drag on the left here, and one with drag on the right. Now, without the drag, we can see that there is a terminal velocity in the x direction only. However, even though it is not in a vacuum, it is still, the x direction is not being inhibited during the fall. However, since drag counteracts the velocity, we also notice that a lesser distance is seen in the with drag side in the both x and y directions. We see here that the y direction with drag is never reaches as high of a magnitude as does the no drag. And with the x value, the distance, the magnitude from the axis is less far with drag. Now, in comparison to the real world testing, we see that there is no terminal velocity for any of the three. We notice that it's not in a vacuum and it cannot reach the speeds that it is supposed to when it is uninhibited by forces. We also see that the peaks are not as high with drag, where since the equation is negative, there will always be a force of drag acting against whichever direction it is. So when it is going in a positive direction, it will never reach as high as the simulation without drag. And we also know that the distance is lesser due to the previous slide. Now, these values are very small. We only travel for about 0.6 seconds, and we are only traveling a distance of maybe 1.5 meters. So their error in the tracker is a lot more obvious with this small data. And so we can see that it stays a bit above on the y value, and it stays in between the two on the x value. And it is a bit wobbly due to human error on that. Now, this is inside, so the drag is lesser. However, the speed is also low, so the drag does stay at similar levels throughout both code and the real world. Now, for our conclusion and a what if that we have, we're wondering if the object was shot directly upwards or thrown directly upwards, would that affect the time that this object is in the air? Now, first to analyze this, we have to see that the component breakdown of velocity is in the x direction of cosine and the y direction of sine. So if this was purely in sine, we know that it would travel higher than if it was being broken down with two different components, intuitively. And second, we know that the force of gravity is only acting in the y direction. And so we can derive t from this equation that we are given. And we see that the time will be greater solely because there will be nothing changing the time if there is a greater force in the y direction, since the x direction's force does not affect the time that is traveled. And overall, this experiment shows non-negligible forces that act on projectiles and was an enjoyable study to make. Thank you.